Hi everyone, my name is Henry Gamboa. In this presentation, I will walk through the concise comparison between Snowflake and Amazon Redshift, focusing on their technical differences, cost structures, and which platform better supports data-driven workloads like churn analysis. Let's begin. To make this comparison practical, I'm using a company persona named StreamWave Telecom. They serve around 800,000 customers and rely heavily on analytics, but they struggle with seasonal workload spikes, outdated on-prem systems, and limited database administration support. Their goal is to adopt a cloud warehouse that scales efficiently and supports BAI dashboards and churn prediction. Snowflake is a fully managed cloud-native platform designed for flexibility. It separates compute from storage, meaning warehouses scale independently without affecting other workloads. Billing is per second and warehouse auto-suspend, which helps control costs. The biggest advantage is that Snowflake requires no tuning, no indexes, no vacuuming, making it ideal for teams with variable or unpredictable workloads. Amazon Redshift is AWS cluster-based warehouse. It delivers strong performance, but it requires tuning, things like sort keys, distribution keys, and baking jobs. Scalability and also affect performance because resizing or rebalancing the cluster might interrupt queries. Redshift integrates very well with AWS services, but is generally a better fit for engineering-heavy teams with predictable workloads. For a typical 1 terabyte analytics workload, Snowflake costs around $143 a month thanks to per second billing and auto-suspended. Redshift, on the other hand, costs around $785 a month because compute runs continuously, even when idle. Snowflake becomes more cost-efficient when workloads fluctuate, while Redshift becomes cheaper only with long-term reserved instances. In terms of performance, Snowflake scales instantly with no downtime, and multiple warehouses allow teams to run workloads independently. Redshift can scale, but resizing the cluster might lead to temporary disruption. Performance in Redshift also depends heavily on proper tuning, which adds ongoing operational work. To summarize, Snowflake's main strengths are simplicity, flexibility, scaling, and minimal maintenance. The trade-off is that costs can increase without good governance. Redshift's biggest strength is deep integration with AWS, but it requires more tuning and scaling effort, especially during peak analytics demands. For StreamWave Telecom, Snowflake is the better fit. It provides the flexibility they need to handle variable workloads, lower maintenance for a small team, and offers cost control through per second billing. This makes it ideal for churn analysis, BA, dashboards, and future analytics growth. Thank you.